What if I told you a defense contractor just built a combat-ready weapon system in less time than it takes most people to renovate a kitchen? 84 days. That's how long it took Sweden to go from concept to battlefield deployment with a counter-drone platform that's now raising eyebrows across NATO headquarters and forcing the United States and the UK to rethink how they build military technology. By late 2025, a troubling reality had set in across Europe. The continent was dangerously unprepared for swarm drone attacks. What Ukraine and Russia had been dealing with for years was no longer a distant problem. Drone incursions were probing NATO airspace with increasing frequency, and traditional defenses were proving wildly inefficient. Yes, systems like the Patriot missile battery and Germany's Iris-T could take down incoming threats, but at what cost? Firing a $4 million interceptor at a $20,000 drone isn't just wasteful, it's unsustainable, especially when adversaries can churn out hundreds of drones daily, while NATO allies produce interceptor missiles by the hundreds annually. The math simply doesn't work. That's why, between 2026 and 2030, NATO countries and close partners are expected to invest over $210 billion in air and missile defense upgrades. A significant portion of that budget is earmarked for high-end systems designed to counter cruise missiles and ballistic threats from Russia and Iran. But billions are also flowing into a newer category: affordable, scalable, rapidly deployable counter-drone solutions. Enter Sweden's Loki system, a modular anti-drone platform that didn't reinvent the wheel. It just assembled the right wheels faster than anyone thought possible. The 2026 Global Counter-UAS Systems Directory cataloged more than 1,000 anti-drone solutions from over 550 companies worldwide. These systems span 11 categories: net capture devices, autonomous ground units, detection arrays, directed energy weapons, electronic countermeasures, kinetic guns, integrated platforms, interceptor drones, missiles, munitions, and software-driven tools. Loki doesn't fit neatly into one box, and that's exactly the point. What makes it unusual isn't bleeding-edge artificial intelligence or some experimental laser, it's the speed and pragmatism with which it was built. Swedish defense giant Saab, short for Svenska Aeroplan Aktiebolaget, founded in 1937, looked at components it already had on hand and asked a simple question: what if we just combine these? The result was a mobile, Lego-like defense system that merges Saab's Giraffe 1X radar with its Trackfire remote weapon station, adding electronic warfare modules for jamming and signal disruption. Together, these pieces form a multi-layered counter-drone platform capable of detecting, tracking, and neutralizing threats through both kinetic and electronic means. And because every component was already in production and widely fielded across NATO forces, training requirements and interoperability challenges were minimal. The US, UK, Canada, and Sweden already operate Giraffe radars. Trackfire weapon stations have seen action from Finland to Ukraine. Loki simply brought them together in a new configuration. Unveiled in February 2025 through a collaboration between the Swedish Air Force, the Swedish Defence Materiel Administration, FMV, and Saab, Loki represents a fundamentally different approach to defense procurement: build fast, test fast, deploy fast. Let's break down what makes the components of Loki so effective and why they matter to US and UK defense planners watching this closely. The Giraffe radar family has been in development since the 1970s. The first units rolled out in 1977 alongside Sweden's RBS-70 surface-to-air missile. Early versions were mechanical pulse Doppler systems designed to spot low-flying aircraft in cluttered environments, think forests, mountains, and coastal terrain. By 2014, Saab introduced the Giraffe 1X, a compact X-band active electronically scanned array, AESA, radar purpose-built for mobility and rapid deployment. Unlike older mechanically steered radars, AESA technology allows the beam to move electronically. That means faster target acquisition, better reliability, and the ability to track multiple objects simultaneously. Critically, the Giraffe 1X offers 360-degree coverage and completes a full volume scan every single second. It can detect what military planners call LSS targets, low, slow, small objects like consumer drones, on top of providing early warning for rockets, artillery, and mortar fire. The land-based variant has an effective range of roughly 47 miles. The naval version extends that to about 61 miles. Weighing under 330 pounds, it can be mounted on light vehicles, rooftops, or masts, and operated either remotely or on-site. In 2023, Saab introduced a deployment set to improve field readiness. A year later, they added a compact radar module with a foldable antenna that tucks into its housing at the press of a button. The system integrates seamlessly with command and control networks, meaning data flows freely between sensors, shooters, and decision makers. It's no surprise demand has been strong. The US military, the UK Ministry of Defense, Latvia, and Sweden have all procured Giraffe systems for various roles. Now, the same radar serves as the detection backbone of Loki. On the engagement side, Loki uses the Trackfire Remote Weapon Station, first showcased at the DSEI Defense Expo in London back in 2007. Trackfire entered operational service with Finland's Navy in 2012. Sweden formalized domestic integration in 2017, mounting the system on Combat Boat 90 fast assault craft. Since 2022, Sweden has provided Ukraine with 21 aid packages worth $11.3 billion, including Archer self-propelled howitzers, Stridsvagn 122 tanks, and at least 26 CB-90 boats equipped with trackfire stations. 10 boats were delivered in February 2024. Another 16 arrived in January 2025. Combat feedback from Ukraine heavily influenced the next iteration, Trackfire Ares, unveiled at DSEI 2025. Ares is optimized specifically for counter-UAS missions. It supports 360-degree rotation and an elevation range from 20 to plus 155 degrees. Compared to competitors like Norway's Kongsberg Protector, South Korea's Hanwha Naval RWS, or Germany's Rheinmetall RMG-30, Trackfire's elevation range is modest. But where it excels is precision. The system features stabilized independent line of sight, or silos. The sensor module operates independently from the weapon mount, meaning it's isolated from recoil. Operators maintain continuous visual contact with the target, dramatically reducing engagement time. The system can also continuously laser designate targets mid-engagement, feeding real-time data into ballistic calculations and 3D target prediction algorithms. Trackfire is modular by design. The director unit houses the sensor module and connects to a human-machine interface that includes a gunner's display, fire control panel, and video tracker. Operators can identify, prioritize, and engage threats without breaking screen contact. The ARS variant comes standard with a 30mm M230LF Bushmaster chain gun, but it's compatible with the Browning M250 caliber heavy machine gun, the FN Mag 58 7.62mm machine gun, Mk19 and H&K GMG 40mm grenade launchers, and lighter missile systems. Non-lethal options like dazzlers, smoke launchers, and loudspeakers can also be integrated. For Loki, the loadout includes a Browning M2, an FN Mag 58, and electronic warfare jammers. That dual threat capability, kinetic and electromagnetic, gives operators flexibility most systems lack. You can shoot a drone down, or you can jam its control signal and force it to crash. Either way, the threat is neutralized. And here's the kicker. It only took 84 days to make this operational. 84 days. Let that sink in for a moment. Most Western defense programs measure timelines in years, sometimes decades. The F-35 program began in the 1990s. Literal combat ships faced repeated delays and budget overruns. Even incremental upgrades to existing platforms often take 18 to 24 months. Loki went from evaluation to fielded system in under 3 months. This wasn't a typical product development cycle. It was what Saab called a speed run. A deliberate experiment to see how fast Sweden could respond to an emerging threat using existing technology. Carl-Johan Bergholm, Senior Vice President and Head of Saab's Surveillance Division, explained the approach. We had to think outside the box. By cleverly repurposing existing products and integrating new features, we brought the concept together at record speed. The Swedish Air Force and FMV didn't wait for perfection. They prioritized speed and battlefield utility. Evaluation started in January 2025. By April, working prototypes were in the hands of Swedish combat units. Then came the real test. In September 2025, Saab confirmed that Loki had been operationally deployed in Poland for 6 months. Swedish forces from the 21st Wing and later the 17th Wing used the system at Malberg Air Base as part of a NATO mission to secure logistics hubs funneling military aid into Ukraine. Lieutenant Colonel Christian Bertilsson, the Swedish contingent commander, kept his assessment measured. Effective air operations require robust ground protection. The systems we deployed significantly strengthened base security, both for us and our allies. But photos told a more detailed story. Stenciled markings on the Loki units indicated 36 quadcopter-type drones and 17 fixed-wing UAVs successfully intercepted during live operations. The system's construction was decidedly low-tech in appearance, radar mounted on pallets, secured with elastic tie-downs, powered through extension cords, likely running to portable generators. A red shipping container bristling with antennas served as the jamming module. Nothing was painted. Everything was functional. It looked improvised. And in some ways, it was. But it worked. That utilitarian aesthetic might be a problem if Saab wants to sell Loki internationally. NATO interoperability standards are strict. Regulatory wiring protocols, electromagnetic compatibility requirements, and certification processes could slow things down. The current Loki setup would need refinement before the US Department of Defense or the UK's Defense Equipment and Support Organization could formally adopt it. But here's the broader point. Loki proves that speed and modularity can be viable strategies in modern defense acquisition. Major General Jonas Wickman, Chief of the Swedish Air Force, put it bluntly. This is a clear example of how we are building the capabilities required, and that we are prepared to deviate from normal processes to meet today's threats quickly. We need to constantly evolve and find fast, competent solutions. Loki is scalable. It can be upgraded with additional sensors, new weapon mounts, or directed energy attachments as technology matures. It can operate while moving, providing continuous coverage during repositioning. It integrates with layered air defense networks and shares data across platforms in real time. How many other NATO systems can claim that? The drone threat isn't going away. If anything, it's accelerating. The Iranian Shahed 136 has reshaped how militaries think about aerial bombardment. Even the United States reverse-engineered captured units to develop its own low-cost loitering munitions. High-end systems like Patriot and THAAD remain essential for countering ballistic missiles and advanced cruise missiles. But Ukraine could burn through a year's worth of PAC-3 interceptor production in months, if supply could even keep pace. The old defense procurement model, lengthy development timelines, high unit costs, limited production capacity, may not survive this new era. The future belongs to systems that are agile, affordable, adaptable, and rapidly scalable. Systems like Loki. Sweden just showed NATO what's possible when you stop waiting for the perfect solution and start building with what you have. The question now is whether the United States, the United Kingdom, and Canada are willing to follow that lead. We'll be tracking how this story develops. Counter-drone technology is evolving faster than almost any other military domain right now, and new systems are being announced nearly every week. If you want to stay ahead of the curve, make sure you're subscribed. There's a lot more coming.